Good morning, students. The next topic we are going to see is about relation between F and R. Okay. So what is F is? F is the focal length. R is the radius of curvature. So we are going to see the relation between this both. Let us consider a concave mirror for this. In this, consider a parallel ray. So, a ray which is parallel to the principal axis, after reflection, what happens? It passes through the focus. So, it is passing through the focus. Okay. Then, from this point, we are joining to the center of curvature. Same way, from this, if we draw a perpendicular, that point is considered to be the pole. Okay, because this is the center, that center should be the pole. Here since we are drawing the perpendicular, this is considered to be the pole. Okay, and here this is the incident ray, is it not? And so this is said to be the angle of incidence I, and this is a refracted ray. Here it has to be written as R, but they both are same value, so here also it is written as I. Okay, if suppose this is I, then this value is also I, because they are opposite angles. Okay, so sorry, this angle is I, and so this angle is also I. Clear? So now we are going to find out with this value. So already we have with only two values of I, because this is a incident ray and this is a refracted ray, and here we have the two values of I. This is angle of incidence I. Here is the angle of refraction, but here since both the values are same, here also it is written as I itself. Okay, then here also we have the value of I. Okay, now on this two side we have the value of I. How to find with the exterior angle in this? We know the property, the exterior angle is equal to sum of opposite interior angles. Okay, so this can be written as I plus I. Okay, so I plus I is what? 2I, and so here the angle becomes as 2I. Okay, so that is what is written here as 2I. Clear with this? Okay, so this angle and this angle are equal, so this is the opposite angle, then the exterior angle is equal to sum of opposite interior angles. So we are writing this as 2I in this. Clear? Now let us consider C to be the center of curvature, and a light ray which is parallel to the principal axis incident on the mirror and passes through the focus. Okay, so light ray which is parallel to the principal axis incident on the mirror and it passes through the focus. Okay, next is the geometry of reflection of the incident angle is shown in the figure. Then the line CM is normal to the mirror at the point M. From C we are drawing M, yeah, that is normal to this mirror. So in the mirror how it is? It is normal. Normal means what? Perpendicular. Okay, and let I be the angle of incidence, and same will be the angle of reflection also. Clear? Then so from M we are drawing a perpendicular, is it not? So MP is a perpendicular, and from geometry we know that the angle MCP. So MCP, the angle is what? I. Next is MFP. Okay, so MFP, the angle is what? 2I. So I told you how to write with this value of 2I. Okay, now taking with the triangles. So what are the triangles we are going to take is MCP and MFP. First take with the triangle MCP. Okay, so here we have M, and here is P which is right angled, and here is C. So here the angle is what? I. So we are writing this as I. From this we have to find the value of tan theta. Okay, so what is the formula for tan theta? Which is equal to what? Opposite divided by adjacent. Okay, so what is the opposite side of this angle is PM divided by the adjacent. So what is the adjacent side here is PC. Okay, and instead of this angle theta we can write the value to be this, which is what? I. So tan I is equal to PM divided by PC. Clear with this? Same way, if you are going to take with the next triangle. Okay, so what is the next triangle they are taking here is MFP. Okay, so MFP, it is drawn in this way. Here is M and here is P, and here we have the value of F, and it is 90 degree at this point. F, the angle is what? 2i, and so here it is written as 2i. Same way, tan theta, what is the formula is? Opposite divided by adjacent. Okay, so what is opposite side here? It is PM, and so we are writing this as PM divided by P, that is adjacent, and so it is PF. Okay, so we are writing as PF. Yes, so now instead of theta, what is the angle here? It is 2i, and so we are writing this as tan 2i is equal to PM divided by PF. Clear with this? So this is the value of tan I and tan 2i. Next is, if we consider the value of tan to be very small. Okay, so tan வந்து ரொம்ப small இருந்துச்சுன்னா, neglecting with the value of tan here, so we'll just write with I alone. Okay, so I is equal to PM divided by PC, and 2i is equal to PM divided by PF. Okay, now this value of I we are going to substitute in this place. Okay, so we get 2 into PM divided by PC is equal to PM divided by PF. Both the side cancel with the value of PM. So we get 2 divided by PC, okay, is equal to 1 by PF. Just multiplying this side, and so we get 2 into PF, which is equal to PC. Clear? Since we are multiplying this term, this side, we are getting as 2 into PF is equal to PC. Now, what is the value of PF and PC is from the pole, if we measure with F, okay, that is what focal length. Okay, then from the pole, if you are measuring the center of curvature, that is what R, and so instead of PF we are writing as F. So 2 into F, which is equal to PC is what? R. Okay, so this is a relation, 2 into F is equal to R, and that can also be written as F is equal to R divided by 2. Okay, so this is one more relation. Clear? So this gives a relation between F and R. Thank you.